In this video, I want to explain to you how the RSA encryption algorithm works without any step skipped. As any asymmetric encryption algorithm, we need a public key to encrypt your message and a private key to decrypt your message. Yeah, in the case of the RSA algorithm, we need a public key that is NE. N is called the modulus, and E is called the public exponent, and the private key is the modulus together with the private exponent. Okay, so these we need to calculate based, which we will do now in an example. Yeah, first we will calculate n. For n, you need to come up with two secret prime numbers. Let's say p equals 3 and q equals 11. These are your secret prime numbers from which you can calculate the public modulus n by just multiplying p and q. Of course, in reality, p and q are way larger prime numbers, so that once you multiply them, it is very, very hard, nearly impossible to find out p and q again. Yeah, so multiplying is easy. Finding the two factors from which this number 33 originated from is very hard. So now we have the modulus n. Now we still need to calculate the public exponent e. For this, we have to first calculate something that is called Euler's tangent function. We will not explain it here in depth. You can Google it. Yeah, all you need to know is that this needs to be calculated to derive e. So this is just calculated by p minus 1 times q minus 1, which equals 2 times 10 is 20. Yes, this is called Euler's tangent function, and now e is just a number that is greater than 1 but smaller than the value 20, and at the same time co-prime with phi of n. Co-prime means that they don't share any divisor other than 1. Yeah, in this case we can, for example, choose e equals 3. Yeah, it is larger than 1, it is smaller than 20, and it does not share any divisor with 20. So that is e, and now we already have our public key, so I just call it pub key. It is 33 and 3. Yeah, this is the key that we will use to encrypt the message. Now we can calculate the private key d. Yeah, d needs to fulfill the condition that d times e modulus the tangent function equals 1. So so d times 3 mod 20 equals 1. Yeah, modulus just means subtract this number as often as possible from this number here until it's not possible anymore, and what's left is the value here. So clearly here one can derive it very easily. Let me zoom out a bit. (21) mod 20 is of course 1. So 7 times 3. D must be 3. Sorry. D is 7. Okay, so that is your private key. Equals 7. Or we can also put n first. 33 and 7. D can never be found out unless you know P and Q, because remember, this Euler's torsion function can only be calculated if you know P and Q. And Euler's torsion function you need to derive D. Okay, let's now maybe go through an easy example. Let's say we have a message that is 4. That's the secret message. And we first compute the ciphertext using the formula. So we now go through the RSA algorithm in an example. So the ciphertext C is just m to the power of the public exponent modular n. Mod n. So 4 to the power of 3 mod 33. Four to the power of 3, that's 64 mod 33. So we can subtract 33 only once. What's left is 31. That is our ciphertext. Yeah, that means that is your encrypted message. Now we decrypt. For the decryption process, as I said, you need D, the private exponent. So for this, we just do the same operation again. We take the ciphertext this time, so C to the power of the private exponent modulus n. So that's 31 to the power of D was 7 mod n. N is 33. Now it's very hard to calculate 31 to the power of 7, of course. There are efficient algorithms to calculate this. But in the end, if you type it into calculator, you end up with 4 again. So this was a video explaining to you how one derives or determines a public key pair, and also how to use it to encrypt a message and decrypt it again.